Lesson 3. Merge sort. The central feature of the merge sort algorithm is the merging step. The merging step takes two sorted sequences and merges them into one sorted sequence. Here we have two sorted arrays. To merge them, we continually take the next smallest element and put it into a new array. For illustration, we will make the elements that we are comparing light gray, and the sorted elements will be shown in white in the bottom array. We start by comparing the smallest elements of each array, the 4 and the 1. Since 1 is smaller than 4, we put it into the bottom array and go on to the second element of that array. Next, we compare the 4 and the 3. Since 3 is smaller, we put it into the bottom array and move on to comparing the third element of the second array. Now we compare 4 and 9. Since 4 is smaller, we put it into the bottom array and move on to compare the second element of the first array. Comparing the 7 and the 9, we take the 7 and put that into our sorted array. Then we go on to compare the 14 and 9. Since 9 is smaller, we put it into our bottom array and go on to compare 14 and 17. Since 14 is smaller, we put it into the bottom array. With only the 17 left, we add that to our bottom array and finish the merge step. Here's how the merge step is used in the merge sort. Suppose that we have an unsorted array like this one. We can think of this array as 8 little sorted arrays, each with one element in it. Then we can merge each pair into a larger array using the merging step. For illustration, we will make the arrays that we are merging gray, and the resulting merged array white. So we start with the elements 9 and 2 and merge them into a 2-element array. Then we merge 5 and 6 into a second array, then 3 and 10, and finally 1 and 7. Now all of our elements are in sorted 2-element arrays. Next, we move on to sort the 2-element arrays into 4-element arrays. Lastly, we merge the 4-element arrays into a single 8-element array to finish the sort. For the merges that we did, we need to allocate a new array for each merge. That's 7 arrays for this particular sort. There are ways to implement a merge sort with fewer allocations, however we chose to do it this way to simplify our explanation. An example C++ implementation is available on our lesson page at soax.net. Here's the pseudocode. The outer loop starts at 1 and doubles the index for each loop until the size of the array is reached, which is given here as size. This variable I is the size of the arrays that get merged. The inner loop increments by twice the value of I, or twice the merging array size, since we merge two arrays. Inside this loop, we call the merge function to perform the merging step. The first argument is the address of the first element of the first array to be merged. The second argument is the length of the first array, which is always I. The third argument is the size of both arrays, where the second array ends based on the pointer to the first array. This is usually 2i, but may be shorter for the last merge of each loop. The merge function takes these arguments and merges the two arrays and places the result where the original arrays were. The first line initializes the indices for merging. I, j, and k are the indices for the first, second, and merged arrays, respectively. This first while loop runs through the elements of the two arrays to be merged and copies each next smallest element to the temp array. The temp array is an array that we allocate locally inside of the merge function. When this while loop terminates, we have copied all of the elements from one of the arrays into the temp array. We just need to copy the remaining largest elements. We do this by running these two while loops which copy the remaining largest elements from the first or second array. This final for loop copies the merged elements from the temp array back to the original array.